Hydrology is the study of water, water movement, water distributions, and management. For highway designer, the primary focus of hydrology is the water that moves on the Earth's surface, and that part ultimately crosses transportation arterial such highway stream crossings. And second interest is to provide drainage for the roadways and mediums area interchanges such. Hydrologic cycle is a interchange of water from the ocean to the atmosphere to the land and back to the ocean. It is a constant interchange. As is shown in picture, when warm, moist air rises up to the level where condensation occurs, and then precipitation occur in forms of rain, hail, sleet, and snows, and then it will fall on the watershed.
Four important parts of hydrologic cycle for highway designer are precipitation, infiltration, storage, surface runoff. To calculate surface runoff, we can subtract losses from precipitation. And losses are known as evaporation, interception, transpiration, and infiltration. There are a couple of important instructions to determine the surface runoff. There are infiltration, depression storage, and detention storage. Detention storage is water that temporarily stored in the depth of water that's necessary for overland flow to occur. Infiltration depends on soil type, slope, temperature, vegetation, moisture content, and rainfall intensity. We can use Horton's equation to determine infiltration capacity at any time. The equation shown in here, and the curve that's shown in the figure represents the infiltration rate through the time. The infiltration rate is higher at the beginning of the rainfall, and it decreases as times go by, and it reaches its final steady state in infiltration capacity. And anything above the curve will become runoff. There are a few important characteristics to highway drainage are intensity, duration, time distribution of rainfall, type of storm, movement, and frequency. For watershed analysis, we can use rational method, USGS regression equation, and RCS unit hydrograph. The drainage area must be less than or equal to 200 acres to use rational methods. If we have drainage area that is larger than 200 acres, then we can use unit hydrograph or regression equations. Watershed characteristics or drainage area, and runoff depends on it. And we have slope. It affects momentum of runoff and can trigger erosion and sedimentation. And we have roughness. The greater roughness can lower the peak charge, and it will take longer time to reach the outlet. And next we've got storage. If we have some sort of storage within the watershed, it'll decrease the peak discharge. We have drainage density. Drainage density is total channel lengths per unit area. And we have, if we have higher drainage density, then it will cause the water to move faster than low drainage density, and we often see that in urban area. We have channel length, it's the distance of the flow path, and we've got antecedent moisture. The rational method was developed in 1989, and it was widely used method. And there are several assumptions must be made before using rational method, and basic assumptions are peak flow occurs when entire catchment is contributing, and drainage area have to be less than 200 acres, like I mentioned earlier. Rainfall intensity is uniform over a duration of time equal to or greater than time of concentration. And the equation is Q equals CIA. Rural runoff coefficients are determined by using terrain, land use, and soil type. NRCS has come up with the soil group. We have Group A, Group B, Group C, Group D, based on topography and vegetation. Urban runoff coefficients is just a function of land use and watershed slope. If we're designing for less frequency storm, then we will need higher runoff coefficients. The runoff coefficients provided in EPG are just for 5 to 10 year frequency flow. If we're designing for 25 year, then we'll have to multiply the C value by the frequency corrector factor, which is 1.1. And every watershed has different type of soil, and since they don't obtain the same type of soil and land use, we will have to calculate the composite runoff coefficients. It's just the summation of C times A over the total area. That will give you weighted runoff coefficient. Time of concentration is the time that required for water to flow from the hydraulically most remote point of the drainage area to the point under investigation, like your project location. And it needs to be calculated to analyze the rainfall intensity. It is also the summation of trouble time of flow regimes. We have overland flow, we have ditch flow, we have open channel flow, and we also have storm sewer system flow. We can use Kirby-Kirby's method for rural watershed. Kirby-Hathaway methods is best for overland flow time calculations. The length of overland flow should be limited to less than 500 feet, and this method can be used for urban watershed as well. For urban watershed, we use the same method plus the other appropriate channel flow times. And for example, like open channel flow time and storm sewer flow time. Kirby's method is best suited equation for open channel flow that mimic the natural streams. Some area may obtain flat slope, and it might result in large values of time of concentration, and we don't want that. Therefore, the slope shall be adjusted by adding 0.0005 if slope is less than 0.2%, and we can use adjusted slope to calculate the trouble time. Rainfall intensity is function of duration, frequency, and location. And it can be determined by using IDF curve or intensity equation. MODA provide IDF curve for each district, and they can be found in EPG. Now we know how to calculate time of concentration and rainfall intensity, so we can calculate runoff discharge. And example calculations are shown in next 5 slides, so you can look through it and see if you can calculate. time of concentration, and rainfall intensity and runoff discharge. Regression methods is function of return period, area, slope, or basin shape, and standard error. Three sets of equations are available in EPG. We have urban regression, we have rule 2014, and rule 1995 equations. And both 2014 and 1995 equations were developed for three regions shown in the figure. Regression analysis helps us understand the relationship between the variables, and it also helps determine the flat magnitudes with the various recurrence interval by using data collected from stream gauge, and it also statistically predict the outcomes. And the rural regression equation 2014 is the function of watershed area and the basin shape. So the value used for the basin shape is calculated by dividing the square of the longest flow path, or just stream length, by the drainage area. Valid data 2014 regression equation can be found in MODI EPG. Keep in mind it only helps to determine the region. It is not used for determining the validity of the equation. Standard error is the standard deviation of error, and it's a measurement of a sampling variation of the statistic, and also the standard deviation of the residual in a regression analysis. It is also based on the number of degree of the freedom associated with the errors. Urban regression equation is function of drainage area and impervious area. The drainage area range is from 0.28 square mile to 189 square mile, and the impervious area is in percent. It's from 0.23% to 46%.